Welcome to Thoughts and Discourses on Digital Transformation. Dive into a world of insightful conversations and profound ideas.
A big overview of application modernization and the 6Rs. We're going to start to do a series of deep dives into them. And probably one of the most important, most discussed is the refactor. This is one of the big Rs. And it's really talking about how are we going to look at our application that we have, how are we going to refactor into a modern set of technologies. And there's probably a couple of options that we have for an individual application, Big Bang and Strangler. And we'll talk through that and then talk through, some of the other aspects of that, how we can migrate to the cloud. Is there any AI tools? And then things like containerization, would that help with us? And then talk a little bit about databases. We might end up having a whole separate section on databases. So welcome back, Maverick, and welcome back, David. So look forward to another great conversation. So Maverick, maybe you go up first and talk about, the Big Bang and Strangler Fig patterns and why would we do one over the other?
Okay, so usually when we're talking about the refactorings, Big Bang and a Strangler is very popular, two different approaches. Based on my personal experience with field of the modernizations applications, my personal experience with that is Big Bang. Usually, if we have applications relatively simple or there's less dependencies with others, so that means Big Bang will be the first choice. The reason is this one has a clean start and they will know all the things as a one shot. So there's no high risks. And that's the things. Let's say once you get the things ready, it is ready. So this is not going to last a very long time. It's a clean cut. It's pretty clear. So the Strangler, actually, most of our applications, especially consider for this refactoring, usually they are last there for decades or more than that. It's long history. And more important is the most likely those applications are critical to the enterprises. So the Strangler usually will be the proper approach for that. So the Strangler means incrementally replace the legacy system pieces by pieces internally. And the good part for that is the risk is manageable, it's incremental risks. So that means easily to test and deploy particular changes to that. And this is a continuous deployment. And the cost for that is usually the need a lot of the deep knowledge about the new usually we say it's a greenfield applications such as microservices, the domain-driven designs, very, very deep understanding of those things. And otherwise, the system will become to fall apart. That's usually the things. In addition is another, I think this is a side pros or side good parts for the Big Bang, which is we don't necessarily carry over a lot of the tech depths during the process. So everybody focusing on the new systems. But for the Strangler, the old system and the new system must be coexist for a very long time. So the old technical depths have to be carried over for a while. So that's the overall things, I think.
Yeah, that's great. And I think with they call it the Strangler Fig pattern. The other way is, piece by piece, right, is migration. I think sometimes it's more expensive to do it that way and more complicated because you have to keep the legacy technologies as well as some of the newer technologies running in parallel. So that makes it a little bit harder. But David, have you seen, Big Bang migrations and Strangler piece by piece migrations? Which one do you prefer and why?
Yeah, it's a tough one. I think it's, again, it depends on some of your business drivers. It depends on your environment. But what Maverick was saying, I absolutely agree with. I think the more experience I have had with Big Bang, and I think I mentioned this a little bit last time, the more I've experienced delays and higher costs. And I think the reason behind that is back to sort of the unknowns that get you. And if you have somebody trying to sort of estimate whether it's cost or effort, a Big Bang refactoring project, people are guessing. I mean, there's no doubt they're guessing because of all these unknowns. I certainly, this is my personal preference. I prefer the Strangler Fig type of methodologies. I haven't specifically used, that type of approach, but more incremental. It tends to be safer. I think you're right. It'll take longer. Is it costly or not? I think that's probably debatable. But I prefer the incremental side. And I think, if you think about the three risks, right? You've got your known unknowns, your known knowns, and your unknown unknowns. And this third one, your unknown unknowns, are always the ones that bite you. And I think if you do an incremental approach, you can address those as you come across them and instead of trying to have this long analysis process up front, trying to figure everything out. But it's not always, practical or possible to do an iterative approach, especially if you're trying to change architectures midway through. But
yeah, and how would you go about reducing your risk? So one example I've seen is production parallel or silent mode validation, sometimes it's called, where you run both systems in production. You end up at the end of each day, for example, if it's a batch system, comparing the output of both systems, and then you can see any differences in your new system and decide, is it a bug or is it a requirements defect, or is it actually a bug in the existing legacy system that you've found, and what do you do with that bug? Do you keep it or do you fix it in both systems? So, I'll turn it over to you, Margaret. How would you go about reducing your risk as you do this refactoring of, a large enterprise application?
Yeah, so that's the thing. One of my experience about that is, we need to have the parallel verification environments up and running. So not necessarily means the silent test mode, but also the things, the target or the old work, what we call it, reference systems. That's just existing legacy applications. They're functioning well. And the other one is stood up as our new build Strangler applications. So that is replacing pieces by pieces here. So that means this two systems must be stood up. And same input supposed to get same output. That's the testing or verification principles. Not just the test for a day. We need to constantly testing for that. Let's say if we have one features ready on here as the testing, so the same input will be yield the same output. And those things must be tested in the production environment for a while. Let's say usually we will test 3 months or something like more than that. And then once this one ready, and almost every scenario we encountered in the production has been covered here, that means we have enough confidence to promote these pieces to the production. So next pieces will come in. Using this way to constantly deploy and changing the productions, eventually everything will be rolled out to the more modern way. So in order to do that, so the same input you'll always have the same output. We can have usually, for example, we have enterprise level system integrations. Usually the legacy system through the IBM queue, for example, that way. So the IBM MQs, we can leverage the queues of reporting queue. That means once the request comes into one queue, we are not going to inject the same functionalities as an existing system. We can have assigned to that. So how to do that? For example, let's say the IBM MQ, they have a feature called a reporting queue. We can just, once the message comes to here, we enable the COD and generate a report queue, the same messages. So the new verification system will consume from there, and they compare to the result. So those things must be set up like that. And more important on top of this, will be the automation comparison systems. So they cannot just manually compare the result. They have to use the systematic way to compare the result and generate the report. Use that way to trigger this editing refixings or enhancement to make the new systems, the new pieces working with the whole legacy, there's a straggler patterns work. That is a very key things to ensure the quality of the delivery and ensure this approach is success.
Yeah, exactly. David, what have you seen with trying to implement big systems into production, especially with making sure that they're consistent? You know, a lot of things can really bite you, and especially with legacy systems, the lack of documented requirements. So you get these special edge cases that no one ever remembers, and they're, you know, well embedded in the code, and they might run at month end or quarter end or weekend. So have you seen that? And then what are the strategies that you've used to mitigate these risks?
Yeah, I'm going to build off of what Maverick was saying there. I think, for me, it's automation, validation to make sure that things are working as intended. And when I say that, I don't just mean QA, the typical QA validation for test case execution, but I'm talking about validation on the back end, wherever your data is going to end up, whether that's in a data store, whether it's in an integration. If you can automate the validation of where that final transaction rests, that is the key. Now, I think that becomes harder and harder as you're changing architecture platforms, because it's, you've got double the expense, but you've got double the expense anyway with trying to retain two systems while you're trying to refactor. So again, I'm a big fan of the automation and validation on the back end.
Okay, and let's move on to migrating to the cloud, right? Everyone talks about cloud migrations, and there's a lot of complexity behind that. So let's assume we have like a mission critical large application, and we want to migrate that to AWS or Azure or GCP. David, maybe we'll start with you. What would be your strategy with that, especially if you're taking a piece-by-piece migration? Would you move some parts to the cloud and have hybrid on-prem and cloud? Or would you wait until that whole application is migrated or basically rewritten and then migrate that wholesale? What are the different strategies that you've used in migrating at the same time refactoring applications into the cloud?
Yeah, that's a great question. I think if you wait while you're writing something, you're starting to push towards the rewrite R instead of the refactoring R. And like I said before, those kind of blur together. But you two have more experience than I do in the microservices side, but it's a great example of if you're refactoring an on-prem application and you want to move to microservices, you can move both your data and your services tier up to the cloud and start building those microservices with components still running on-prem. And you can refactor over time. Again, this is back to the incremental approach. There's pros and cons to it, but you could certainly do that. I've done that a few times in some of my large enterprise applications. Again, it takes longer. There's no doubt about it. But I argue that it's more expensive for many reasons and many measurements. But that's one example you could look at.
And Maverick, what have you seen? Have people implemented like internal cloud solutions? Normally, it's Pivotal or OpenShift first, or do they just migrate directly and refactor onto the cloud as they go? What have you seen?
Okay, so my thing is, so when we're talking about the migrate application to cloud, that is one thing. Usually, when we're saying this, really behind the scene is we would like to build an application environment agnostic. So that means they can run almost in any kinds of environments. However, with today's the IT trends, so more and more applications are going to run in a container. That will fulfill for this journey. let's say, as long as I run in a container, I can push to the Dockers, to push to the Kubernetes. So every cloud environment, as today they have, Kubernetes supported. So that means indirectly, I can run my application every places. That is one approach. So that means we will just, we're just using certain level of the services provided from the cloud provider. Just use this infrastructures or this container level. That is one approach. We call it as a horizontal, cutting all the cloud providers. Vertically, I recently, we know this one thing is another way to do that way. The Azure, Microsoft Azure, they have a Microsoft Azure Cloud, and they have a Microsoft Azure Stack. So they're pretty much the same thing. And the stack is pre-built that everything's from bottom up, and you can just run your application deployed to here. That means you have abilities to promote it. Your application run in the stack goes to the public cloud, and you can demote it from public cloud running back here. Using that way to maintaining the cloud migration. But that is this is a vertical way I would like to say. So that is this is based on purely based on the cloud providers' capabilities to do that work. So in addition, actually for that is deploy to the cloud, or there's a hybrid deployments. Yes, definitely we can do that, but most likely they have a certain of the challenges we have to consider. First one is the date synchronizations, just now as Dave mentioned, and the other one is the network latencies, because usually the public cloud side, it runs in the public cloud, and the private sector is running in the company managed the data center. Those latencies, these are some things we have to always keep in mind. And the security, especially the sensitive data, access, security, everything. And also another thing is the cost. Because yes, when we're talking about the things we deploy to the cloud, the cost is very safe, and the cost is not a concern. But actually, there's a lot of the things unpredicted if we're using the cloud environment for running your application. This is a lot of the cost associated with that. Have to be keep in mind. That's the things.
Yeah, I just want to chime in on that. If you Maverick, if you are Kubernetes based, you can use micro-K8s on and off the cloud so much more adaptively than you can almost any other platform.
Yeah,
that makes a difference in the world. Now, I do think personally, Kubernetes can be more complex than sometimes I like, but that's a great example of being able to be flexible, moving up and down like that.
Yeah. For example, let's say, usually now we have more and more applications from the traditional monolith or the query based to the event driven and microservices based applications.
Yeah.
So there's a lot of the frameworks already there to support that usage. For example, one of the popular things called the Spark or a Flink. So there's a Flink, they can run in a cluster mode, and a Flink cluster can run on top of the Kubernetes and leverage the Kubernetes to do the resources allocations, horizontal scale, and so on and so forth, high availability. So use that way, you almost have your application always running 24/7 and without hassle of the monitoring and the downside. So that will be the trend for that. Together with just now, as you mentioned, everything runs in the Kubernetes. That is the great things to hide a lot of the down details there down there, right, in the different cloud environments. So that approach combined, you can also deploy your streaming applications in any places.
Yeah, so David, I think I've just finished, on-prem container implementation. If you were to go migrate to the cloud, what would be your concerns? Would it be connectivity? Would it be immediacy, latency? What would be your concerns in doing that?
Yeah, I think a couple things. One thing is no matter how standard of architecture is, you're going to have differences running on-prem versus the cloud, bottom line. Even though you're still using, you're using micro-K8s up in the cloud, using Kubernetes on-prem, there's still difference in the way things behave. Now, it's not the end of the world, but you just have to be aware of it. And those are some of the gotchas. But the biggest thing is your network architecture on how you not only connect both from a resiliency perspective, but a security perspective, and trying to move your security principles on-prem up to the cloud, is not a simple task. It just has to be really well thought out, and that resiliency and redundancy has to be there. If you have that dependency, that's high on your list of priorities.
So, Maverick, there's an awful lot of talk in the industry about generative AI, Gen AI tools, as well as retrieval augmented generation, the RAG tools as well. And I think GitHub, which is a large vendor, Microsoft product, right, has brought out Copilot. Amazon has a product called Q out there that will really help developers. So what have you seen with these kind of tools? Have they helped development teams, or are they more hype than reality at this current time?
Okay, so I know there's a ton of the Gen AI tools today is used by different use cases, specifically for this kind of the refactor and focusing on building the new applications and run in the cloud. If it goes that way, the Gen AI things definitely will help on different levels. I think in the first level, this can help on the code refactor, such as the Copilot, just now you mentioned, and also together with some other tools, very popular. There's another one's a Type 9. I think that is another one, right? Yeah. So that tools can help to, suggest the modernizations, refactoring, rewriting the code, more better way to suit the destination environments. That is from the development perspective. From the unit test perspective, there's a certain other tools such as Deep Blue. So that tool can generate necessary testing cases to cover all your codes there, positive, negative, and edge case. That is another tools. I do believe everyone will use the CI/CD pipeline for deployments. So the SonarQube, they have AI modules. So if we can enable that part, that also can benefit from that as well. So that's just more from the development perspective. From the environment perspective, let's say deployment dependencies maybe. So when we move from the legacies, the VM to the cloud, so we need to know what things we need to depend. Any services we can directly use from this particular cloud environment. For example, this is a tool from AWS called Application Discovery. I think that's that name. Application Discovery Services. That one can help and suggest the migration plan and the steps. That could be AI parts for that if we target it on the AWS. Some others, let's say the integration testings. So there's a lot of the tools for the integration testing area, including I think in my head is a couple of the, let's say Testim. Yeah, Testim could be one of the tools we can consider to use for execution, the automation test, integration testings. So that's the AI is used everywhere.
So, David, I think you just finished up a big application development effort. Did your teams use any of these Gen AI automation tools, or was this? And do you think that's going to start to happen?
Every day, and we paid for the paid versions of it. That's how valuable it was for people.
Where was the value? Was it speeding up development? Was it speeding up testing, or just?
It was more on the development side. I think the testing, testing probably at least the project that I was on, it wasn't quite as probably mature as some other organizations. But the development, there's a couple of benefits to it. Number one, just kind of time to figure out how to do something. Even that you knew how to do it was just tremendously valuable. But a lot of the senior engineers trying to figure out how to do something new that they've never done before cut the time of implementation by 80 to 90%. It was unbelievable. And I'm going to know the answer to this. I'm going to ask both of you, who on this call has ever used generative AI to write code for them? Raise your hand.
I just use not use the Gen AI write code for me. I use that one to generate the unit test a lot.
Oh, yeah. Well, that's a great example too. I mean, it's unbelievable. Like my personal opinion is that is the most valuable piece of technology that has been out in the last year for developers. I just think the productivity you get out of that is amazing. Remember I talked last time about that Microsoft Access client that I had? Well, I didn't want to admit this, and I don't consider myself a developer anymore, but they had asked me to write some code in that Microsoft Access environment, and I was, I almost got depressed. But ChatGTP wrote it for me in about 20 minutes. Yeah. And I was so excited. But again, I think the value of that is going to continue to increase. I can't say
It's
more positive things about that.
It's very positive, to be honest. So, when we're doing the development, we're more concentrated on the how we're going to handle this, how we're going to handle that, the structure thinking, the logic for the business cases. So when if we need to develop the enterprise level or enterprise grade applications, we have to make sure all features we build here must be tested and tested once. So if we spend the same amount of the time to build the test cases, and even the test cases need to debug as well. So all the things put together, you can think how much time we have to spend on a feature. However, if we leverage the AI to build the things for the testings, and we concentrate on the actual business logic, so you can see the time at least spend less or half. Yeah.
Well, and that's where the value is, right? Of what we do.
Yeah.
That's where the value is.
Yeah,
the value is in selling code.
Even ThoughtWorks, which is a large, consulting company, Martin Fowler works for them. He's kind of, the guy that came up with Strangler Fig pattern definition. His group actually did an overview of some of the dev tools and their performance improvement. I think it's going to be, really, it'll just accelerate more and more.
Yeah.
And here's, full disclosure, the intro video that was, 20 seconds long for this was actually done by generative AI.
Was it really?
Yeah, it was. And so you can see in basically a few dollars and a few sentences, I can create like an intro AI, including all of the music that was generated. So, that's just the thing, right? It'll really going to speed up some of the improvements, and we should probably do a deep dive on your Access DB problem, David. And
I want to bury that one.
Yeah. So probably the last thing is, and we'll probably need to do another session on database migration because we're about out of time, right?
Yeah.
There's a whole bunch of newer technologies. Classically, a lot of people use SQL databases. Pick your Oracle, MySQL, SQL Server from Microsoft. Now there's a whole bunch of new technologies, right? NoSQL technologies.
Yeah.
So Maverick, as we go into these refactoring, do you see more and more people looking at these NoSQL databases, whether it might be columnar or tabular databases, and what has been the impact of performance improvement or flexibility by leveraging these tools, and what's the downside?
Okay. So for those things, actually, I would like to step back a little bit, one step back, because it's, we know this is the NoSQL is always attracting people by performance. The old applications or the legacy systems always built on either the schema-based file reset or the RDBMS. So first the challenge is about the schema mappings. So the schema mappings from the relational databases to the NoSQL is quite challenging because different NoSQLs, they have a different way to organize the data. So you have to select the proper way for that particular NoSQL database. So for example, the Cassandra and the MongoDBs, they completely different animal. So that typing will be different. For the other things is that the query, yes, they have a very fast queries in the let's say in the NoSQL databases. However, the NoSQL databases is designed for reading, not for writing. That means we need to build the CQRS model for your applications. Let's say the write the data into the databases might be that's in the one type of a schema. That is for write, for validations, for relational check-ins and everything. But when the read, that either for the reporting or for the end results, so the data usually denormalized and must be collocated together. So that will be the cases to store those data into the NoSQL databases. In between the structured one and the normalized one and the denormalized one, so the some things we have to build in the middle called a CQRS model. So this is a very common model usually used for this kind of the data integration or migration.
And David, what have you seen with leveraging different database technologies as you go through, refactoring?
Yeah, I think I've so through some of these refactoring projects that I've been on and sometimes have led, the primary time we ever switch database platforms is when we're migrating up to the cloud or when we're moving up to the cloud or refactoring to the cloud. I haven't had a ton of instances where, you've got an application on-prem that's written in Oracle and you have somebody that's going to switch it over to SQL. And again, that's back to my long-winded point last time about business value and not technology value. But things like some of the AWS tools, Snowflake, some of the platforms like that, I've seen a lot of people starting to move towards. In fact, I think Snowflake stock just went up here just this past week on positive results. So I know that's growing. It's been growing for a while. But I haven't seen a lot of NoSQL implementations yet. I mean, I know it in principle. I hear it in the news, but I have yet to experience someone go to NoSQL. At this point, I'd love to hear more of either your perspectives on that.
Yeah, I think we'd have to do a different session and give some examples of when and where. So we're about out of time. So Maverick, any last thoughts on refactoring applications?
Yeah, refactor applications is quite complicated. At the very beginning, when we're talking about that, it's driven by different factors. So there's no one approach for all this type of things. So we have to understanding each approach's pros and cons. And even though within the Strangler, they still have a certain of the steps, such a certain of the approaches, such as outside in, domain-driven, or API-driven, or interfaces-based. There's so many approaches. We have to carefully select a proper way for a proper application.
And David, final thoughts?
Yeah. Just a couple of things. I think, again, I am more along the lines of the incremental approach, conservative approach. If you're talking about refactoring data, even if you're moving up into Microsoft SQL on-prem to Microsoft SQL in Azure, they're different. The cloud stuff is always different. There's some differences in the data types. There's difference in some of the query language. And so you just have to expect that no matter what you're doing, there's going to be refactoring involved from a data side, from a code perspective. These platforms don't run the same in both these environments. And then finally, I just want to know from the two of you, did I get more respect today from you two that I'm wearing a jacket?
Very much. We're definitely jealous. We'll have to up our game for our next time. I think I'll be in a tux. So
it was only because I came from an event. That's all. So
okay. So that's it for today's session, and look forward to recording a few more, talking about some of the other R's in application modernization. Thanks, everyone. Thanks, guys.
Thanks, guys. Appreciate it.
Bye.